Hello?
Wait, what were you doing? I kept on calling you just now, but you didn't answer. Don't tell me you just woke up,
Since it is weekend, so of course I sleep until now lah. So what did you call me for?
No wonder. Anyways, will you be free tomorrow?
Yeah, should be free. Why?
I was thinking of going camping at our old place tomorrow. Do you wanna come? Yiek and Jennifer will be joining us.
I have to ask my parents for the permission first. We'll get back to you later.
Okay, but you better don't go back to sleep.
2 hours later.
Hello, Sim.
Hey Ben, my parents allow me to go camping with you guys.
After a decade, finally you call back. Did you continue to sleep just now?
Never mind that. What time do you reach tomorrow?
For considering the chance for you to wake up late, we decided to put at 10 a.m.
You know me well. See you guys tomorrow then. I have to go and wash my shirt now. Bye.
Based on this picture, we can see that the wet shirt has become dry after drying under the sun for a day. The heat from the sun makes the water molecule of the wet shirts, on average, more energetic so they have more chances to escape. Heating the water molecules enough and all the molecules will eventually evaporate. So, one way to dry wet clothes is heat them, turn the water they contain into steam, and then extract the steam so dried clothes are left behind.
The next day.
Hey, Ben, good morning.
Yeah, morning. Just wanted to remind you to bring the ice cubes later, as I will bring some soft drink as well. I repeat, don't forget.
Yes, sir. I won't forget to bring it. If I forget to bring it, I treat you to all the boba drink you want, deal?
Hey, deal. Let's jam.
Hello? Where's Jennifer? She didn't forget, did she?
I just texted her and she says she almost reached.
Hey, speaking of the devil.
Sorry, I'm late. And thanks for waiting.
It's okay, you're on time. Anyways, Yiek, did you bring the important stuff I reminded you just now?
Of course. I have the ice right here. Hey, where's the water in the plastic? Ben, did you steal the ice?
Of course no! Why would I want to steal the ice in the first place?
For the boba drink, of course.
Wait, but for stop! Don't you know about the melting of ice?
Huh? What is that?
Can you explain?
This occurs when the internal energy of the ice increases. The ice temperature also increases to the melting point. Then, when the temperature reaches the melting point, the temperature remains constant as the heat is added because the heat energy is used for breaking the hydrogen bonds between the water molecule, which is latent heat to change the ice into water.
And that's why the ice disappeared.
Makes sense.
Better remember this in future. Now, let's set things out.
A few moments later.
Yeah,
Yes?
please take good care of this water. I will entrust this job to you.
Oh, no problem. Small case only. Easy.
Hey, since I have nothing to do, let me accompany you lah.
Okay, sure.
Welcome to Mobile Legends.
Ben, can you help me to take care of this for a while? I'll be right back.
Okay.
Legendary! Double kill!
Ben, why did the water become lesser than before? Did you steal it again?
No, I didn't. Why would I want to steal the water in the first place?
Because... I don't know either. Never mind!
Relax, guys. Ben didn't steal the water. The concept is actually same with the ice becoming water.
Huh? What is that?
Explain now.
It is simply that when water is heated, it evaporates, which means it turns into water vapor and expands. At 100 degrees Celsius, it boils, thus rapidly evaporating. The water which has evaporated then becomes invisible gas, which is steam. This process can be summarized in the heating curve and the cooling curve of water. For the heating curve, this part is the part where the melting or fusion of ice occurs, and this part is the part where boiling, evaporation, or vaporization of ice occurs. While for the cooling curve, this part is the part where condensation of steam to water occurs, and this part is the part where freezing of water into ice occurs. During these four processes, the temperature remains constant as the heat is added. This is called latent heat. The latent heat absorbed or released can be calculated with the formula Q equals mL, where Q is latent heat absorbed or released by a substance, M is the mass of the substance, and L is the amount of heat required to change the phase of 1 kg of the substance at a constant temperature.
Makes sense.
You guys can leave it to me now. I'm going to cook soup.
Then I shall go ahead and make the campfire.
Jennifer, does your hand feel hot holding the ladder?
Oh no, I don't feel hot because the ladder has high
Specific heat capacity.
What is that? Can you explain more?
Oh, easy. Allow me to explain.
Based on the formula of heat, which is Q equals to mc theta, Q is the amount of heat required, m being the mass of an object, C is the specific heat capacity of the object, and theta being the change in temperature. According to this formula, we can see that specific heat capacity is inversely proportional to the temperature change, which means that the higher the specific capacity of an object, the lower the temperature change of the object. Since the handle of the ladle has high specific heat capacity, a high amount of heat will only cause a small change in temperature. Therefore, the handle of the ladle will not get hot too fast, and this phenomenon explains why Jennifer's hand won't feel hot while holding the ladle.
Oh, then how about the pot?
Oh, for the pot, it is the total opposite. The pot has low specific
capacity. Well,
Since the pot has low specific heat capacity, it can be heated up quickly even when a small amount of heat is applied due to the inversely proportional relationship between specific heat capacity and temperature change based on the formula of heat. When specific heat capacity of an object decreases, the temperature change of the object increases. And that's why the pot heats up quickly.
Wow!
A few moments later.
Guys, the campfire is ready. Come and sit around.
Let's go.
The way of heat transfer can be summarized based on this picture, which are conduction, convection, and radiation. The first way of heat transfer is conduction. Conduction is heat transfer by molecular contact. A simple experiment can be conducted to show conduction. For this experiment, you need to prepare 2 polystyrene blocks, a steel rod, a candle, a lighter, a small plate, and some butter. Firstly, the polystyrene block and the steel rod are set up as shown. Make sure the metal rod stays firmly in place. The candle is fixed on the small plate by melting the wax at the base of the candle. The butter is then cut into 3 small identical pieces and placed firmly on the metal rod exactly 5 cm apart. Based on this experiment, we can see that butter A falls off first, then butter B, and finally butter C. Energy from the candle flame causes the molecules within the metal rod to vibrate, transferring the energy from one molecule to the next until the entire metal rod has warmed up. The molecule nearest to the flames are the first to vibrate, transferring heat energy outwards and traveling to the nearest molecule and so forth. The first part of the metal rod to get contacted by heat energy is under butter A. Therefore, butter A softens first, making it fall off. The heat energy continues to travel along the metal rod, reaching and melting the butter B secondly and finally butter C. The second way of heat transfer is convection. Convection is heat transfer through density differences, which occur more effectively between liquids and gases. There are two types of convection, one being natural convection and another being forced convection. Natural convection is a type of flow of motion of liquid such as water or gas such as air, in which the fluid motion is not generated by any external source but by some parts of the fluid being heavier than other parts. The convection can be shown by sea breeze and land breeze. As we can see, during the daytime, the air above the land warms up and rises, and the cool air over the sea moves in to take its place, resulting in a sea breeze. On the other hand, at night, the sea maintains its temperature better, and therefore makes it warmer than land. The role of land and sea reverse, and this convection of air results in the land breeze.
Besides natural convection, we also have forced convection. Forced convection is a special type of heat transfer in which fluids are forced to move in order to increase the heat transfer. This phenomenon can be shown with a lighted match. Based on the lighted match, we could see that the heat generated by the flame rises due to convection as the flame causes air to expand. When air expands, it becomes less dense than the surrounding air, therefore floating upwards with some of the heat energy.
The third way of heat transfer is radiation. Radiation is heat transfer by wave motion. This phenomenon can also be shown with a lighted match. Since we know that heat rises due to convection, heat also travels outwards in the form of electromagnetic waves of energy. Radiation does not need a material for it to travel and can also occur in space, such as how energy travels from the Earth's sun to the surface of the Earth.
Very nice. Oh.
Today was a knowledgeable day.
Yes, I agree.
Me too.
Michi!
Wow, guys, look at the sky.
Whoa!